Poverty is one of the most pressing challenges facing the world today. It affects millions of people across the globe, depriving them of their basic needs, rights, and opportunities. But how do we know where the poor people are and how to help them? Well, poverty mapping is a technique that uses data from satellites to estimate poverty indicators at small areas. It can help us to fight poverty by identifying the needs, characteristics, and impacts of the poor, and by designing and monitoring better policies and programs. Poverty mapping is a powerful tool for fighting poverty and has been used for various purposes and applications around the world. In Vietnam, poverty mapping has helped to inform the allocation of public resources and to support the decentralization of poverty reduction efforts. In Colombia, poverty mapping has helped to identify the most vulnerable municipalities and to prioritize social investments. In India, poverty mapping has helped to measure the multidimensional aspects of poverty and to analyze their spatial patterns. In today's tutorial, we're going to be using a newly released NASA dataset on global poverty to also do some poverty mapping. So join me as we dive into some powerful and very useful data visualizations. Hello people, this is Milos. Welcome back to my channel as I take you on another data visualization and geospatial journey with R. This time we're gonna be mapping poverty using a newly released NASA Global Gridded Relative Deprivation Index, and we will be mapping poverty levels in India. First of all, I'm going to show you where you can find this data. Second, how you can load it into R. Then I will also going to show you how you can create a very effective map of poverty by Indian states using zonal statistics. And then finally, I will show you how you can create also a very effective 3D map using rayshader. All right, we're gonna kick off our adventure by first of all installing and unloading the packages that we need in our session. We're gonna create an object called libs, and then within this list, we're gonna provide the names of the libraries that we wanna install and then load. The first one is the umbrella package, Tidyverse, which has packages for data wrangling such as dplyr, and also data visualization such as ggplot2. Because in this tutorial, we're going to work with the substate level of India, we also need to get a package that will allow us to import those state boundaries of India. And for that, we can use our geo boundaries package, which provides access to global administrative boundaries data. So this one, it's very important to actually emphasize. You should not be using cron to install this one. In fact, I think it's going to throw an error if you try to do that. So the best thing is to simply install it from the source code, which is in GitHub. And to install from the source code, you first need to have a remotes package, because remotes package will allow you then to access GitHub install. So GitHub install, which will then provide you access to this package from the repo. And the repo for this one is digoa and then slash rgeo boundaries. Apart from these two packages, we would also like to have some other. So because we're dealing with shapefiles, we definitely need an asset package. Then the poverty index data itself is in the raster format, and because of that, we will need Terra package to deal with raster files. Now, for calculating the average poverty index for every Indian state, we also need to employ zonal statistics, and for that we can also use, for example, Terra package. So finally, one of the things that we can also plot here and visualize is using 3D maps. And for that, we can definitely use a rayshader package, which we have used also before. Now that we have the list of libraries that we want, first of all, we need to check if these are actually installed on our system. So we are actually gonna take this list, libs, And then we're gonna look through the ROM names of the installed packages on our system. Now, if these are not installed, so if any of the install libs, in other words, equals false, then we need to open up an if statement and here tell R to actually install packages. But not all, only those from this libs list that are not enlisted among the installed libs. And finally, once we have this, we simply need to load the libraries into R. Because we operate here with a list of libraries, we definitely need to use lapply function. And then within this one, the list is going to be libs, and the function we want to apply is library. Library function in R is used to load packages. So once we have this, and once we actually run everything, we should be able to get what we need. Our first task is to load the shapefile of the substate boundaries, in this case Indian states, that we will then use to crop that global poverty index raster file. And the way to load the subnational boundaries is very easy. We will first of all create an object called Indian states, and then we're going to call to rescue RGO boundaries, and specifically one of its functions here, which is called GB_ADM1. So this will return you administrative level 1. So the first substate level in India, which is a state. For some other countries might be something else. So there are other options here. If you choose, for example, GB_ADM null, it will return you simply the country boundaries, so devoid of any substate divisions. So we're going to go for this one here. And then to return the subnational boundaries for a specific country, here you need to provide the ISO3 code. So for India, that's INT. Unfortunately, the state boundaries of India, which we got through this RGO boundaries package, do not correspond to the official state boundaries of India. And for that reason, we cannot use this package in this tutorial, which doesn't mean that you cannot use it for other countries. But I found another solution on GitHub where one of the users posted the 2020 official state boundaries of India. So we can actually go ahead and download this data. We just simply need to click here on this link where all the files are zipped and then download them into R. So we can also do that programmatically in R. So if you copied that link from the GitHub page of the user, you can simply define it here. So as URL, and then you can write download file. And then with this one, you can provide a URL. The second one, you want to provide the base name of the URL that you want to download. And then finally, for the mode, you want to use the binary mode, which is here at WP. Once you download this, one thing that you will notice is that the file itself needs to be unzipped. The name of the file will be master.zip. So we just need to do here unzip, then provide a name, which is master.zip. Once you actually do this, once you unzip this, you will see that there is a folder that is created there, and the name of the folder is this: India state and country shapefile updated January 2020 master. So this is the folder, and then within that folder you will have also the state boundaries. So we can then load those state boundaries like this. We can rename them again India states, and we can use from the asset package the command called stread. So this is going to read the shapefile, and then over here we first of all, in the form of a string, we put the name of that subfolder, and then slash, then we put the name of the file itself, and the name of the file, and you can also check the directory into which this was downloaded. It's India state underscore boundary.shp, which is a shapefile. Okay, so once you have this, once again, this is the name of the subfolder. Of course, it is going to depend where this was downloaded, so keep that in mind. Slash, and then just the name of the shapefile, which is India underscore state underscore boundary.shp. Once you have this, you are good to go. And once you actually run this whole thing, it will download the zip file in your local drive. It will download it to your working directory. Then you can unzip it, and finally this will load the Indian states into R. And as you can see, this looks much better. Finally, we have the official state boundaries of India, and we can proceed with the next step, which is loading the raster file into R. One of the most exciting geospatial news that I so far encountered on Twitter is this one, where NASA announced its new relative poverty and deprivation data on a global scale at 1 kilometer resolution. So I was fascinated also by this map, and I decided to click on this link and check out what's going on here. This NASA product is actually called Global Grid Relative Deprivation Index, or GRDI. It's version 1. They did it together with the Center for International Earth Science Information Network at Columbia University. And as you can see, it's a pretty recent news. So it's a beginning of July this year. So if you scroll down, you can then get more information about it. So this characterizes the levels of multidimensional deprivation poverty, which means it takes into account different aspects. It's at 1 kilometer resolution, so quite actually crisp, I would say, for such a complex phenomenon as poverty. And values of 100 represents the highest level of deprivation, while 0 is the lowest. What is important is this was actually built based on different sources, which were harmonized, indexed, and then weighted into 6 main components. And inputs were selected from the data that is available based on those components. So since we're talking here about the index, it also is important to understand what are its main components. So here you can see, how this looks like, what it did here, but methodology is key here for understanding how they actually constructed this. And if you go to the methodology here, there are of course a bunch of stuff that you can see, but for us the most important thing is what are the actual data sets that they used. So in terms of the data sets that they used to compile this GRDI, the first one was the degree of urbanization, or as they call it here, built up area. So basically this is simply the ratio of the urbanized area to non-urbanized area square kilometer. So this was the first one. So if you have a high level of urbanization, that is implied that you have a lower lower deprivation. Another one was the child dependency ratio. So this one is the ratio between the population of children to the working age population. So if you have a dimension where higher values, they imply higher deprivation. So you want to have like a balance here. Another one is infant mortality rates. This one has been for a long time associated with lower development. So the higher you have infant mortality rates, that meant usually lower development around the world. There are other ones, such as, for example, the Subnational Human Development Index. So you can see this one is indexed on its own. And there is also Subnational Human Development Index. So another one that they use here. And they also used night lights, which is, again, also associated with activity, with development, with infrastructure development. So they use this also in a way, if this is very low, then you probably have higher deprivation. So they use here actually 2 aggregates. So if you are interested actually in finding out more about the methodology, like how they put this together, how they actually aggregated everything, I really suggest that you go, through this document and see what's going on. But for now, we can take this at face value. I am pretty skeptical of indexes, but in this case, we can give it a try, especially that this index has been aggregated for a period, so from 2010 to 2020. So it's not like taking just 1 year. It's trying to understand the deprivation over a prolonged period of time. All right, guys, this is the place where the data is located. It belongs to the Center for International Earth Science Information Network at Columbia University. So it's co-hosted by this center and NASA. Over here, you can see quick description of this dataset, but if you want to dive into data, then please click on this data downloads tab. Once you do that, however, the system will prompt you to log in into Earth Data, which is the main client for this dataset. If you don't have the Earth Data account, you will need to register over here in this newly created window. If you're not sure how to do that, if you are clueless, then check out one of my previous tutorials where I show you how to register at this service and how then you can, fetch the data. But once you actually register, you fill out these details, you click on login, you are good to go. And then we're gonna go back to that tab where we can download the data. Once you logged in, you will be prompted back to the data download page, and over here you will see what you can actually download. And first of all, you will see what this download actually includes. So geotiffs, a README file, and the PDF documentation. So if you want to download both GRDI and all those data sets used to build it, you can go for this first file, which is almost 500 megabytes, but I would suggest that for this tutorial, you simply download the next one, which is simply GRDI datasets. It's 150 megabytes. So there is a link here to it. If you just click, the download will start, and this will be a zip file. So we will then handle this directly in R. All right, once you downloaded the file, it's in a zip format, so we need to unzip it. Once again, we can use unzip from base R, and then the name of the file that we downloaded. And this is going to be the same name for everyone. Now, of course, we need to add here an extension .zip, and we then just need to run this and unzip it. Once we are done, we can actually load this file into R. To load GRDI, we just need to use Terra rest. Now, the name of the file itself is this first three strings here. So po-map GRDI v1. So the first version of the GRDI. And then very important here, it needs to be .tiff because this is the file format. Finally here, we can create also the name. So we can name the object GRDI so that we know what's going on. And once we actually have this, we can simply run, and this will load the file into R. Now that we have the shapefile of Indian states and we also have the GRDI, we are ready to actually crop only the extent of this raster for the Indian national boundaries. But before we do that, we also need to make sure that the coordinates reference systems of that Indian states and the raster file match. They currently do not match, and we would like them to match. So currently what we have is that the raster file is in a standard WGS84, but the Indian file is in a pseudo-Mercator WGS84. So we will actually convert the Indian state into WGS84. So we're just going to do here Indian states 4326. We're just going to name it that way based on the data. And then we're going to basically transform the coordinates of the Indian states. For that, we're going to use st-transform from the SF package and just type here 4326. So this will make them then align. Now we're finally ready to crop. So we're going to create India GRDI. And for cropping, we can use Terra crop option. And then within Terra crop, we first of all need to specify the name of the raster file that we want to crop, followed by the name of the shapefile that we're going to use to crop it. So that would be the newly created Indian state 4326. Now, this GRDI, we already imported this into R using Terra. But the Indian states 4326 is in the SF format. Terra likes to work with Terra-friendly format. So we need to coerce this Indian states 4326 into a Terra-friendly format. So for that, we use Terra vect, and then just wrap this around our object. Once we have this, we are not done, because while this is gonna crop the area, it's not really gonna discard those raster values that are outside of the Indian boundaries. So for that, we need to perform two more steps. And the first step is to say here that we want to snap everything and keep everything that is inside of the Indian polygon. And then we also need to say that everything that is outside of the Indian polygon, we want that to declare as null values and then simply discard it. For that, we use mask equals true. If you followed all the steps closely, you should get the Indian GRDI just as shown here. In this step, we're going to use Terra to apply zonal statistics and then calculate average poverty index levels for each Indian state. So let us go ahead and create an object called India GRDI ZS, where ZS is simply zonal statistics, and use then Terra and option zonal from that. So here we need to provide only two objects. The first one is the raster that we want to use to get those values. So this is India underscore GRDI. And the next one is the vector file that you want to use. Again, we want this to be in a Terra-friendly format. If it's not, it is gonna throw an error this time. So we simply convert once more Indian states 4326. I actually realized, because I used this twice, I could have also created a separate object and just turned into a Terra vector format. I didn't, but I think it's a good practice if you do. And then you can actually here define what is the function that you wanna, get. If you, for example, wanna get the maximum index for average over Indian states, you here just type fun equals and then min. If you wanna do the maximum, you can do max. If you wanna do the average, you can simply write mean, and this is exactly what we're gonna calculate as well. Now, a lot of these states also have NA values. In other words, the raster that we got does not cover each and every part of every Indian state. So for that, we need to remove any NA values and calculate only based on the values of the raster file that are provided. And for that, we can use simply na.rm, which means NA remove equals true. All right, and once we actually run this, it's not gonna take a long time, because first of all, the raster file is quite small, and also it's calculating for a very limited number of Indian states. And once this is done, I just wanna show you, we got actually a data frame of all the values. So it has 37 values, and here you can see they are from 1 to 37. We have now average values. The thing is, you might be asking yourself, how do I, now know for which Indian state this is calculated? The good thing about Terra zonal statistics is that it's going to order in the same way that they are ordered in your shapefile. So we just need to kind of merge this together with the shapefile of Indian state boundaries, and then we're good to go. Okay, so our next step is to merge both the shapefile of the Indian states and those zonal statistics data frame that we just created. And that's going to be pretty easy. So we're going to create Indian states GRDI, and then we're just going to bind them together. So we're going to use cbind for that. So binding column wise. And then we're going to bind Indian states 4326, which is our main SF object for Indian states. And then we're gonna put together with this India GRDI ZS, which is for zonal statistics data frame that we just created. And then once we run this, and once we inspect, you will notice that we have now here together the state name. We have this GRDI with an awkward name, which we're gonna change in a bit. And of course we have the geometry field. So this is for all the Indian states, 37 according to this data set. So as we said, names for the GRDI are weird. They are weird because they simply inherited the value column from this India GRDI ZS. So we can simply change that, and we can change this using names And here we indicate we want to change number 2, and we can simply name this GRDI. And once we run this, it is going to be changed, and we can also check if it really changed. So we just quickly see this, and as you can see, this is the value and with the new column name. Now that we have all the data together, we are ready to create our first map, which is going to be a Choropleth map, where we will fill the polygons with those GRD values, and then finally we will also print the labels with the value for each state, so that you also know, apart from the color, what is the average GRDI for each Indian state. Let's begin by calling ggplots. So we're gonna call here ggplot and then create our first layer. So our first layer is based on an SF object, so we need to use geom_sf here to call it. And then for the data, we of course define Indian states GRDI. AES is the aesthetics here, which actually defines the column from your data that you want to use, and of course also the method that you want to use. So we're going to use the fill method because we want to fill the polygons of those Indian states. And we're going to use here GRDI. So we want to fill it with the value of GRDI. Now, we don't need anything here within aesthetics, which means that everything you define now outside of aesthetics is going to be the constant that's going to be just added to the layer. And one of the constants here is the color of the national boundary. So we can choose something that is going to be, let's say, charcoal gray. Another constant that you can define is the thickness of each state boundary. Thickness here, we can go, for example, for 0.25. You can also choose some other things, such as, for example, how transparent is going to be this field. We can, for example, go for 0.75. If you choose here, so the value goes from 0 to 1. If you choose 0, that's completely transparent, so you're not going to see this layer at all. And if you see 1, it's going to be, it's going to lack completely transparency. It's going to be completely visible. So that's one of the things. Another layer here that we want to add is the text, and we want to add text as a label, which means there's going to be some kind of a small box, and within that box we're going to put the number. The reason why we're doing that instead of just printing the number is that this is going to give a bit more visibility on it with that let's say white background around it. So usually what happens is, or in the past, what usually happened was you had to provide actually some data frame with your point coordinates and then with the label. There is a new function here, which is called geom_sf label, which actually calculates the centroid for each polygon for you. And then you just need to provide what you want to print on those polygons. So it's a pretty cool thing. And we can use it here as well. The things you need to provide is, first of all, what is the data? So as in the case of the first layer, the data is Indian states GRDI. And then again, within this aesthetics, you need to define what you want to, what you want to change. And that one is going to be the label. So for the label here, we would like to use GRDI and print it there. But the thing is, this one has a lot of decimal places, and I would like to shrink those places to maybe 1 or even 0. So for that, you can use round in R. Rounds, and then here you choose how many decimal places you want to leave. So these are some of the things that you can add, but there are also other things that are, you can hold constant here. And one of them is the color of the fonts that you want to have. So the color of the font, we can again go for charcoal gray. You can also go for the size of the fonts. I found that 2 is quite an optimal size. I found if you decrease, then it's not so visible, but if you increase too much, there's going to be an overlap between different numbers for each of the states. Now, I would like actually to get rid of the edges of those padding boxes. So for that, I can simply say label.size equals NA. So I'm just not going to have any kind of borders around those label clouds. And I can also choose to kind of make it more transparent. So by manipulating this alpha attributes and putting it to 0.5, for example. So these are the two main layers. Everything that comes after this is simply customization that we're taking. And the first customization that we can make is, what are the colors that we want to use for painting those polygons. So for that we use shapefile gradient. And here you can set several things. One of them is, for example, you can set the title of the legend. So we can, for example, set here GRDI. And more importantly, you can set here the colors that you want to use. So I like actually these HCl colors because they allow a lot of different palettes. And one of them that I want to use in this tutorial is a plasma palette, which combines different colors starting from, so on the darker side, it uses navy blue and purple, and then slowly transitions to orange and yellow. So here within HCl colors, you can define the number of colors you want to have. Let's say we want to have 8 colors. We want to grab 8 colors from this palette, and then you can specify here another palette you want to use. So that's plasma. Here there are many other things. Viridis, for example, that one is the blue, green, yellow. Also pretty cool palette. So we're going to go with the plasma one. And then here within this one, you can also specify, what is going to be the alpha level, the transparency or the opacity level of your of these colors. So we can go, for example, for 0.85. So it ranges again from 0 to 1. Simply this is the matter of preference, and you can definitely change this as you wish. So that was the customization of the color palettes. We can also add here our coordinates reference system so that ggplot knows what we are using exactly. So 4326. And then finally, we can also deal with the theme. I really like to use this theme voids because it gets rid of this excess backgrounds elements. And if I had some more preferences, I always can use this theme, and within that one, put additional things. One of the things that I would like to change is, for example, the legend position. So in this app, I would like the legend to be on the right-hand side. And because I chose something like that, I would need to create some more space on the right-hand side of the plot. For that, I can use plot.margin and specify here within this units, I can specify a list of things that I want to change, where each member of the list is one of the sides of the world, starting with the top side, which is T. If I want to shrink, and I do want to shrink the top and the bottom, I'm going to here put minus, and let's say -3. But the right-hand side, I want to increase, so R equals, for example, 2. As I said, the bottom side, I'm going to decrease also -3. And then finally, the left-hand side, I can expand it just a bit, so 0.5. And always remember here to put the unit type that you're going to use, which can also be, let's say, millimeters or centimeters or inches. So this is how you, in short, can specify your theme. And finally, you can also add some of the labs or labels here. And one of the things you can add is titles so that your audience knows what you are doing here. So you can, for example, put here, relative deprivation index 2010 to 2020. And you can also put, or actually I would say, I would encourage you to use also the caption where you can put also the data source. That would be very smart. So you can put here global gridded relative deprivation index. And you can say also here version 1. All right, so this is the code. One thing that I also want to mention here is for these colors that we chose. So currently, as it stands here, higher values are going to be associated with lighter colors, while those lower values are going to be associated with darker. I want to change this. And if you want to change the order here, it's very straightforward. You simply need to use the argument rev and wrap everything around it here. So I just put here rev. Rev means reverse. So it just means reverse this palette that you already have. And that's basically it. The last step that we can take here is actually to save this plot once we run everything. For that, you can use ggsave. Within ggSafe, there are several things that you need to specify. Two are mandatory. The first one is what is going to be the name of your file. So here you specify the name of the file, but always with the extension. So I like the PNG extension or files, and I'm going to use that. The second mandatory thing is what is the name of the ggplot2 object that you're going to save. So this is it. Everything else is not mandatory. So width, for example, I like to use inches here. So for width and height, if you're wondering why it's so small, it's because I use inches, and you can change inches using this argument units. So here I just put inches, which are default, but there are other ways or other things that you can change. You can put millimeters or centimeters as well, and pixels too. And then finally, I just like to specify that the background should be a white color. And then once you run this, we can then see what is the map that we got. And here it is, the relative deprivation index map per Indian state. One thing you will notice that the color of the map in general is a bit darker, which means that the GRDI is higher, which is not good news. But if you zoom in, you will clearly see the variation in terms of the GRDI levels because we printed the GRD values on the map for every Indian state. And another thing that you can notice that the lightest value here is 31.9, which is for Delhi, while the highest one is 79.8 for Meghalaya state. But overall, as I said before, and you can also see if you take a look at these labels, that the values mostly range between anywhere between 64 and 80. So poverty or deprivation is still one of the major themes in India. This tutorial would have been incomplete without also creating a 3D map of Indian poverty, and for that purpose we can use a rayshader. Rayshader has two options. One is you can use a ggplot object and then turn it into a 3D map, but in this tutorial I'm going to show you how you can use the native rayshader option through Plot3D. For that purpose, we will need to use that India GRDI raster object and then turn it into a matrix. So we're going to create an object, India underscore GRDI and then underscore mats. And then we're going to use from rayshader a function called raster to matrix. So this is going to prepare our data for creating that 3D map. Here we're going to pass India GRDI. Once we do that, we can go on and define the texture that we want to use. I'd say let's go ahead and use that plasma palette once more. So we can go ahead and define colors here, just like this, hcl.colors. Let's say we are going to go for 8 base colors from the plasma palette. And one more thing that we can also do here is, as we did in the ggplot2 code, reverse these values so that actually higher values are associated with darker color, while lower values are associated with lighter colors. But of course, in that 3D map, it will be really nice to have a more like a richer texture with more color values. So we're going to create a new object called texture, and then we're going to apply to this color ramp palette, which is going to help us increase the number of colors, and we're going to increase this to 256. This is how you increase from 8 to 256. Now that we have the colors, we are ready to create our first scene using rayshader. So for that, we actually are going to first of all use this India grid mat and then create a pipe here. So the first thing you want to do if you're using this native rayshader option is define your height shade. Within this height shade, you next want to define your texture. So texture equals texture, we already have that. Once you have this, you can go ahead and call Plot3D. Plot3D is pretty similar to Plot.gg that we used before, but there are some exceptions. One of them is instead of declaring here a ggplot object, you need to declare that matrix, which is going to be your height map. So you're going to say here, India GRDI matte. And after that, you can use another argument, which is going to define how tall your spikes are going to be. And this is Z scale. So Z scale here is different from scale in plot.gg in a sense that for plot.gg, the higher the value of the scale, the taller the spikes are. Here it's the reverse. The lower the Z-scale value is, the higher the value of the spike is. So Z-scale 1 is going to be the highest possible given our values. One thing I like to keep off is the solid plane around the plot itself, around the map itself. I like to keep the shadows on, so I'm going to put here shadow equals true. And also I like to change the shadow darkness. The shadow darkness is, the default one is 0.5, but that is still a strong shadow. I like to diffuse the shadow a bit to make it weaker. So I'm going to go with 0.99. So the value goes up to 1. So the higher the value is, the less strong or the weaker the shadow is. So another thing that you can define here is going to be the angle of your source light. So the sun angle, and here it's in degrees from 0 to 360 degrees. 315 that I chose here is basically northwest, but you can definitely play with this one and choose some other angle of your preference. Other things is the zoom level. Zoom level here goes from 0, which means you are completely zoomed in, to 1, which is you completely zoomed out. We're going to go for something like 0.4. And then if you're not happy with this, we can actually modify it. Another thing you can choose here is the angle of your scene. So again, in degrees, and here I'm going to go for a bit of a sharper angle, which is going to be 30 degrees. You can also choose here the rotation angle of your scene along the z-axis. And this one is controlled by theta. Theta can be both negative and positive degree, and I'm going to go here for minus 30 degrees. So we can then see what we got. So if you actually run this, you should be able to see render scene like this. So what you can notice here is that it's first of all, we don't see the entire India. Second, the angle is a bit strange, and also the rotation angle is also weird. If we didn't know that we're working on India, we wouldn't know it, right? So we should change things here, and luckily for us, rayshader allows us to change these things without, rendering the scene all over again. And to actually just modify this scene, you can use a rayshader and then render camera. Within render camera, you can change several things. One of them, we can change the angle. So we chose a very sharp angle. I want to increase this angle to the point where the image almost becomes flat, so closer to 90 degrees. So let's say 85 degrees. You can also change the zoom level. So we can actually zoom out a bit more. So we can increase the zoom from 0.4 to 0.6. And finally, we can also change that rotation angle from minus 30, let's say, to 0. So after we actually run this, you should be able to see something like this. Now, on this scene, you can clearly see India. It's more or less flat, but I really like it. So if you're also happy with the outlook of this image, you can go ahead and simply save it. So you don't need to, spend your machine resources on rendering this in high quality. And the way to save this is the following. So rayshader, and then simply render snapshot. Within this one, you don't need to do much. You just need to specify what is going to be your file name. And let's say this one is India GRDI snapshot. And also you need to specify what is the extension of your image. And I go here for PNG. If you'd like to make one more step and test your machine's capabilities, I'm here to offer you a way to do that with a render high quality through rayshader. So we're going to actually render that object. And as I said, render high quality is the way to go. Here we're going to first of all specify the file name. So let's call it India GRDI dot PNG. And then we can specify some, other things. One of them is, for example, that we do want to see the preview of that window as this object gets rendered. And another thing is that we do want to have the light on the scene. Then we can go on and specify like what is going to be light direction, light intensity, light altitude. If you're not sure how this is done and why we are doing this, you can check out some of the previous tutorials where I do briefly explain what these different things mean. In a nutshell, the first thing is a light direction. This is what is the angle of your light source. And this is what I was referring to in the previous, step, which is exactly between 0 and 360 degrees. So depending on that, your light is going to come from a certain way, and it's going to create a shadow on the other side. So here we're just going to go for the same angle that we specified also in the previous chunk. Another one is light intensity. So this one is how strong your light is going to be. So how shiny your scene is going to be, how bright it's going to be. And this one does not have so much of an intuitive value. So if I say here that I'm going to put 1100, it's not going to tell you much. I can tell you the baseline is 500 for rayshader, but you really need to experiment to get the experience of it to understand what light intensity means. And then the final is light altitude. So one thing that is worth remembering here, light altitude, which goes from 0 to 90, is basically, imagine that your source of light is the sun. So the higher the sun, the brighter the scene is going to be. So here, for example, we can go for 60 degrees light altitude, but you can check and see how this is going to work for you if you increase or decrease the altitude. One thing to keep in mind is this is definitely going to affect the light on the scene. This light intensity, direction, and altitude combined together as well. So these are some of the things that we can define, make the scene a bit different from just using default settings. Other things, for example, is I do like to turn off the interactive mode here, which allows you to actually move the object as it renders. I think it's very resource intensive, and it can actually also break this section. So I'm just going to skip this. I'm going to put here interactive equals false. Another thing I like to turn on is parallel. So I allow this operation to be run on multiple cores at the same time so that this process actually is faster. And then finally, I also like to here define the width and the height, which are by default in pixels. So if I want to go for a bit higher, I'm going to put here width equals 4K and also height equals 4K. But if you find this very cumbersome for your own machine, go ahead and just decrease this. And this is the final 3D poverty map of India, which looks a bit shiny here, but some things that you can notice, those lighter colors are actually urban places or cities that have a lower GRDI, so less poverty, and the darker ones are everything outside of the cities. All right, that's all for today, folks. In today's tutorial, we covered one of the most important topics, which is poverty, using the NASA Global Relative Deprivation Index data, and then loading it into R, where we created a very effective map of poverty levels for every Indian state. In this tutorial, we used zonal statistics to achieve that, and then at the end of the tutorial, we also created a very pretty and effective 3D map with the help of a rayshader. If you're interested in replicating this tutorial, I suggest that you check the link to the GitHub repo in the description below. But I'm really excited about your own project and how you can map poverty levels for other countries or continents. If you have any questions, comments, or just general feedback, please feel free to reach out to me here on YouTube, but also on Instagram and Twitter. If you're new to R, but you're seeking to expand your geospatial and data visualization knowledge, I prepared a few cool tutorials for you. See you next time.